Thank you. Okay, so there are times where it is not particularly convenient to find the area between curves vertically. For instance, this guy right here, we would have to break this up into like 5 different integrals. No, let's not. Instead, how about we take the integral with respect to y, and we take right function minus left function and just integrate with respect to y. Be way better. So our horizontal rectangles have thickness dy. And when we have thickness dy, we need to integrate with respect to y, which means our limits of integration, C and D, will have to be y values. That is supposed to be a minus sign. What? Wow. Sorry, Kylie. Thanks for catching that. Right minus left, top minus bottom. The most important thing you need to remember in this whole chapter. Okay. Are we ready for our first example? Oh, interesting. I feel like we've seen this example before. And what did we have to do yesterday? We had to do 2 different integrals, and we complained about it, right? Let's go ahead and rewrite and redraw. So yesterday we drew our rectangles vertically with thickness dx, and we ended up having to split this into 2 different integrals because our bottom function changed partway through. Today, let's go ahead and use horizontal rectangles because they have thickness dy, and notice how the right side of our rectangle stays on the blue curve the whole time. The left side of our rectangle stays on the red curve the whole time. So we only would need 1 integral. Now, in order to do this, we do need the y value. So I think yesterday we figured out these intersection points. I think yesterday we determined that this was 1, -1, and this was 4, 2. Am I right in remembering that? Okay. So now what we're going to do is we are going to take the integral, just the 1 integral, from -1 to 2. How did I get those? Those are the y coordinates from our intersection points. Okay, now we need the right function. Our right function is, ooh, but we can't write x minus 2 in there. We need to rearrange this to be y plus 2 equals x. We need to solve for x so that we have y's to throw in there. So we have y plus 2 is our right function, minus our left function is y squared. So when we're doing the integration with respect to y, we need to solve our equations for x so that our equations all have y's in them. Does that make sense? Nathan, did I answer a question that you had? I thought you like, no. Then never mind. Misinterpretation there. Okay, now look how much simpler this is, right? Let's do this by hand. We can totally do this. 1/2 y squared plus 2y minus 1/3 y cubed. This is good practice for us from -1 to 2. We got to remember the fundamental theorem of calculus. We can't just like forget about it, right? Okay. What is 1/2 times 2 squared? 2 times 2. Minus 1/3 times 2 cubed. Okay. Minus the quantity 1/2 times -1 squared. Plus 2 times -1. Minus 1/3 times -1 cubed. Okay, well, this is what I notice. We have -8/3 minus 1/3. What's that? -3, right? Okay, and then we have 2 plus 4 minus -2. Okay, so we have 4.5. Whoa. Whoa. Totally what we got yesterday, right? Should we get the same answer? Yes. Yep, same area. Which way was more convenient to evaluate? Totally this way, okay? So sometimes I'm going to tell you, hey, do this with respect to x or do this with respect to y. Sometimes you get to just decide which way is going to make more sense. Sometimes you will not have a choice. I won't give you a choice, but the problem's not going to give you a choice. Case in point. Not until you get to calculus 3. Yep. Calculus is the best. All right, write this down. So what does that make me? Also, right? It's cool. I embrace it. You're just jealous. Hey, we encourage one another. That was uncalled for. You better start being careful. I'll start reporting to your family. Okay, x equals -y squared plus 10. Okay, notice how both of these are solved for x, and they're both parabolas that are opening sideways. So everything is inverted in terms of our shifts. So if we had y equals negative x squared plus 10, that would be a vertical shift up. But in this case, we are going to consider it a horizontal shift right. Okay. If we had y equals x minus 2, the quantity squared, that would be a parabola opening up, shifted right 2. Invert that. Now we have a parabola opening to the right, shifted up 2. So there is our region. Did you ask a question? So when we are inside the square, when we're inside the square, it's backwards, right? Kind of like if we had y equals x minus 2 squared, we would move right 2, which seems backwards. Okay, now do you see how solving for x, or excuse me, solving for y is not going to be pretty, especially in this blue one right here. So being able to draw a horizontal rectangle to complete this problem in terms of y is going to make the algebra a lot easier. Also, notice how our right function is always the pink, is always the pink curve, and our left function is always the blue curve. So we only need one integral. But we got to figure out these points right here. Okay. All right, so let's do some algebra. How do we figure out what those y values are? Okay, x equals x, negative y squared plus 10 equals y minus 2, the quantity squared. Okay, y minus 2, the quantity squared would be y squared minus 4y plus 4. We are going to solve a quadratic. We need this to be set equal to. All right, so we will add over the y squared and subtract over the 10. Solving quadratics. Love it. What can we do to this one? I'm fine. My brain was ahead of my hand. What is this factor to, Cole? All right. So our intersection points, our limits of integration need to go from -1 to 3. Okay. Which function comes first in our integral? Yeah, negative y squared plus 10 because it's on the right, minus y minus 2, the quantity squared, because it's on the left. Okay, I thought you had something meaningful to say. Sorry. Now, here's the deal. I'm going to let you use Math 9. I know that it says y up on the board, but you can use x in your calculator to do Math 9, and it'll give you the number that we need. Okay? Fraction, if it can be. Math fraction. Four thirds? Oh, 64 thirds, you said. Okay. My brother was texting us. They've gotten 7 inches of snow already in Lawrence, Kansas. I know. And like 7 inches. A couple weeks ago, they got like 5 inches also. Like, I know, but don't you want just one day?
I want a snow day. I don't want to know. I want a snow day. I don't want a day or a watch. But I want it to be like nice. I just don't.
Okay, this is our last problem. But yeah, I just want to like have like a wake up. Oh, you don't have to come today. You know what I mean? You know it.
I want it nice up so
Really? Okay.
He's alive.
All right, this is our last problem. And then I'll show you a picture of the coolest pizza I ever got to eat. Oh, no. The place is Colorado.
That's what it's called.
And it popped up in my memories and I feel like.
Called a weekend.
What's the place called? Bojo's. I don't even understand how that's possible. But it was. All right, so we have y equals x squared and y equals 4. So this is our area. And we want to figure out some line, we're going to call it y equals b, that splits this into 2 equal pieces. Ideas. I agree. Now let's do the other thing. Okay. So if we want to split this into 2 equal regions, we can do one of 2 things. We can set up 2 different integrals and set them equal to each other. One for the bottom half, one for the top half. Or what would be our second option? We could figure out what the whole area is and set one of the areas, one of the regions equal to the half of it, right? Which way do you want to do? All right, so let's just find the whole area. Well, I guess, do you want to do dx or dy? Plus or minus the square root of y equals x? Could it be right minus left? We're gonna get there. We're gonna get there. Okay. So what are these intersection points? Y is 4. X is -2 and 2. So we have from -2 to 2 of top function minus bottom function. Find me that. By hand, by math 9, I don't really care. (32 thirds). What's half of 32 thirds? Okay. Now let's come back to, we have this y equals b. And it's going to split this into 2 equal pieces. I don't think I drew it very accurate, but whatever, doesn't matter. Okay. So here's the deal. We need to decide if we're going to do this with respect to x or with respect to y. Now, we would need to know these intersection points right here. We know that y is b, but then we would have to solve for x. Sounds a little bit messy, doesn't it? Okay, so my suggestion would be, well, if we want to just use y, we don't have to worry about x. So let's go with respect to y, which means we would need to change these. This guy would be x equals radical y, and this guy would be x equals negative radical y. Okay, we would actually have to split that into 2 different equations, but that's fine. So now what we can do is we can say, well, our limits of integration would be from 0 to b, right? We're stopping at y equals b. Our right function, radical y, minus our left function, negative radical y, equals 16 thirds. Now it's just some algebra. Radical y minus negative radical y. 2 radical y. So then when we take the antiderivative of 2 radical y, we get y to the 3/2 times 2 thirds. We're going to evaluate it from 0 to b. And remember, this all still equals 16 thirds. Math 9 isn't really helping us right now, is it? Because we're solving for b. B is in our limit of integration. We can't use math 9. Okay, so we have 4 thirds, b to the 3/2, minus 4 thirds, 0 to the 3/2 equals 16 thirds. Now what do we do? Divide by 4 thirds, which is the same as multiplying by 3/4. Oh, this is so nice. So b is 4 to the 2 thirds.